So let us discuss an important concept in binomial theorem, that is the concept of middle term. So middle term is a term of binomial theorem which is equidistant from the leftmost term and the rightmost term. So I can illustrate this with an example. Let's say that you have been given 5 sticks. In this case, we can say that the third stick is the middle one because on the left and on the right there are 2 sticks. Hence, it is like kind of equidistant and in the middle. Let's say that I give you 8 sticks. In this case, the fourth and the fifth stick are in the middle because if you go on the left, there are 3 sticks, and if you go on the right, there are 3 sticks. So basically, you can say that the number of middle sticks depends on whether the numbers odd or even. So on the basis of this, we can derive a formula to calculate the middle term or the middle stick. So let's say that there are t sticks. So if t is odd, the middle stick is t plus 1 upon 2. Similarly, if t is even, the middle stick is t upon 2 and t upon 2 plus 1. Now we will be replacing these sticks with the actual binomial terms. So when we derive, one thing you should remember, that is for the binomial expression which is raised to power n, there are n plus 1 terms. So this means that so we can accordingly derive formula for n and in terms of n rather than t. So basically we can keep t as n plus 1. So our formula would be, if n plus 1 is odd, then the number of similarly, if n plus 1 is even, so in this case our formula would be n plus 1 upon 2 and n plus 1 upon 2 plus 1. Okay. So now we can say that if n plus 1 is odd, then n is even. So if n is even, our formula becomes n plus 2 upon 2, and similarly if n plus 1 is even, n is odd. So our formula simplifies to n plus 1 upon 2 and n plus 3 upon 2. So this is the formula in terms of power of x. That is, if we say x plus y raised to n, so it is in terms of this power. Okay. So now we can basically discuss a few examples of middle terms which will further clear your concept. So one question that I can give you is to find the middle term in this expression. Suppose we have to find the middle term in this. Okay, So we know that 10 is an even number. The middle term would be uh, 10 plus 2 upon 2, and this is 6. So sixth term will be the middle term. Okay. The sixth term in this case would be 10 c5 x upon 3 to power 5 and 9y to power 5. If you evaluate, this will come out to be 61,200 61,236 x to power 5 and y to power 5. Similarly, if I ask you to find a middle term in 3 minus x cube upon 6 to power 7. Okay, so we know that 7 is an odd number, so the middle term would be 7 plus 1 upon 2 and 7 plus 3 upon 2. So in this case, the 4th and the 5th are middle terms. So in this case, this would be 7c3 3 cube and minus x cube upon 6 and 7c4 3 to power 4 and minus x cube upon 6 cube respectively. So this will basically come out to be 35 upon 48 x to power 12 and minus 105 upon 8 x to power 9. So these are the middle terms. So you have to prove that the middle term of x plus 1 raised to power 2n is 1 into 3 into 5 up till 2n minus 1 n factorial times 2n x to power n. Okay. We know that 2n is even. So the middle term in this case would be 2n plus 2 upon 2. This is n plus 1. So now we have to find the n plus 1th term. So this will be 2n cn and this will be x n and 1n. Okay. We know that 2n cn can be written as 2n factorial upon n factorial time n factorial. So basically we can write it as follows. We can write it as 2n into 2n minus 1 into 2n minus 2 so on up till 1. Similarly, n factorial you can write it as n into n minus 1 into n minus 2 up till 1. Okay. Now one thing you should closely observe. If I want, I can cancel out n and 2n. So if I cancel out, I get 2. Similarly, I can cancel out n minus 1 and 2n minus 2. So this will be again 2. So in this way, we can clearly go out cancelling all the terms of n factorial with all the even terms in 2n factorial, and we will get 2. So since there are 2n total terms, so there are n even terms, which means that we will get n 2 times. So it will be a total of 2 to the power n. So we can say that this expression is 2n minus 1 into 2n minus 3 into 2n minus 5 up till and into 2 to the power n upon n factorial and x to power n. Hence, we have proved this.